Hi guys. Today we're continuing with our adding and subtracting rational expressions, but it's going to be more similar to yesterday's lesson, which was fractions within fractions, which is called complex fractions. Yesterday wasn't too difficult. It had a fraction within a fraction, and then you had to, change it to a division problem. But today we're going to put fractions within fractions and adding and subtracting problems. So it just gets a little bit more crazy. There's a reason why they call it complex, because it's a lot. So complex fractions are fractions within fractions that also have adding and subtracting. You can see in this problem, right, I've got the smaller fractions and then I've got the big fraction bar. Now, unlike yesterday's lesson, we are not going to change this to a division problem today. I mean, we could if we wanted to, but I'm going to show you a different way to approach these problems. So what we're going to do is we're going to focus on the tiny fractions, 7 over 12, 1 over 6, and 4 over 9. And we're going to try to find a common denominator for those tiny fractions. So I need a number that a 12, a 6, and a 9 can all change into using only multiplication. Now, we talked about this last week, how to find a common denominator. And so we focus on the larger number, 12, and we ask ourselves, can 6 change into 12 or can 9 change into 12? And the answer is no, it can't. So then we try the next multiple of 12, which is 24. So 6 can change into a 24. But 9 cannot. So 24 is not going to work because it does need to work for all 3 of your fractions. Or if there were more fractions, it would have to work for all of the fractions. The next multiple of 12 is 36, and that's our winner. 12 can change into 36, 6 can change into 36, and 9 can change into 36. So 36 is my common denominator. Now, unlike the other problems that we did earlier, we are not going to make everything have a common denominator. Because then I will still have fractions within fractions, and that's just super confusing. So instead, what we're going to do is we're going to use our common denominator to get rid of the tiny fractions. You can do that by multiplying everything, literally all of the terms, by the common denominator. So in this problem, there are four terms, 7/12, 1/6, 2, and 4/9. Those are each their own term. So each of those is going to be multiplied by a 36. Notice that I put the 36 on top of the fractions. It is a whole number 36. And my goal here is I'm going to cancel out the denominator so that those little fractions are no longer fractions and everything can turn into whole numbers. All right, so like the 36 and the 12, those will cancel to a 3. The 36 and the 6 will cancel to a 6. This whole number 2 right here, it's not a fraction, so it's not going to cancel. I'm just going to straight up multiply 2 times 36. And then on the last one, 36 divided by 9 is 4. Okay. So I just rewrote everything so that you could see exactly what we were dealing with, right? All of the denominators of the tiny fractions disappeared. So nothing is a tiny fraction anymore. And then, I have this 3 and this 7, which I will multiply together. I have the 1 and the 6, which will multiply together. The 2 and the 36 need to be multiplied together, and that did not cancel because there was not a fraction there. And then the 4 and the 4 will multiply together. And now this problem is so much easier, so much less confusing. I'm going to do my adding and subtracting on top. And if I can simplify, I will. If I can't simplify, then I'll say I'm done. So 88 is not divisible by 5. 88 is not divisible by 3. So I think that this is my final answer. All right, so find the LCD for all of your tiny fractions. Multiply each term by your LCD, canceling out the denominators. And then proceed as per usual. Let's do another one together. This one didn't have any variables in it, so let's try one with variables. All right, in this problem, I have two tiny fractions, 1 over z and 1 over z. My common denominator for my two tiny fractions is z, because they both have a denominator of z, right? They have already got a common denominator. So my next step is to multiply everything by that common denominator. Now, in this problem, again, there are 4 terms. There's a z, a 1 over z, a 1, and another 1 over z. So we need to multiply in all 4 places by the letter z. In the terms that were tiny fractions, the z's will end up canceling. So we're multiplying with the sole purpose of then canceling it out and making it go away. In the terms that were not tiny fractions, you do need to actually multiply. So I will need to multiply z times z and z times 1. And so now I have z squared minus 1 on top and z minus 1 on the bottom. I hope you know what our next step is. Our next step is factor. So don't forget, at this point in time, this is in the format that we were starting with the very first lesson of this whole chapter. And our first step on all these problems is to factor. So I can factor the numerator, z squared minus 1. That's a difference of squares. I cannot factor the denominator, but it is a subtraction problem. So I should probably, and I didn't do it on the PowerPoint, but I should probably throw some parentheses around this. All right. And then now I can cancel. So you can't cancel until after you've factored, though. So make sure that you've factored, you've got parentheses around all of your adding and subtracting, and now we can cancel. So I can cancel out the z minus 1s, and I am left with z plus 1. And it's no longer a fraction since the denominator completely canceled out. All right. If you're not feeling too confident right now, let's try some of these, see how you do. And then when you're ready, or just if you get stuck, unpause the video and I'll help you out. Okay, let's check how you did on the first one. So on the first one, my common denominator that I got was x plus 3. And that's just going to cancel out the tiny fractions. But make sure that you are multiplying the number 2 by x plus 3 and that you are distributing it. Here's what I got for my final answer. And then if you need to see my work, here is my work. So I multiplied everything by x plus 3. Very specifically, I distributed the 2 to the x plus 3. I got 2x plus 6. On the tiny fractions, the denominator canceled out, and I was left with just the numerator, the 5 and the 1. And then 2x plus 7, I should try to factor it, but it does not factor. There's no GCF. And so that's just my final answer. So that was the first one. And then let's check the second one. All right. On the second one, my LCD is xy. I need to take all of the denominators from every fraction, and then we're going to multiply in 4 places on this one by the xy. And here's my final answer. Notice that my denominator has been factored. Anytime you can factor, you should factor. And here's my work if you need to see it. So I multiplied everything by xy. On the first tiny fraction, the x's canceled out, leaving me with just a y. On the second tiny fraction, the y's canceled out, and then the red x multiplied with the blue x to make an x squared. On the bottom, this tiny fraction, the y's cancel out, leaving me with just an x. And then over here, it was not a fraction, so I did multiply 1 times xy, which is just xy. And then I did notice that my denominator could be factored. So if you can factor, you have to factor. That's mandatory, factoring whenever possible. After I factored, I realized that I could not cancel anything out, so that's my final answer. This concludes today's video.